Hi everyone, let's solve this problem. Surrounded regions. You are given a M cross N matrix board containing letters X and O. Capture regions that are surrounded. A cell is connected to adjacent cells horizontally or vertically. So given any cell, it can go up, down, right and left. That's what they are mentioning. To form a region, connect every O cell. So let's say for example, this all three cells are O cells. And a region is surrounded if none of the O cells in that region are on the edge of the board. Such regions are completely enclosed by X cells. To capture a surrounded region, replace all O's with X in place within the original board. You don't need to return anything. So let's discuss this. So basically, this entire thing is a region. So we can just replace it with X and we will be able to get this. And why are we not able to this can also be a region, but it cannot be replaced with X because there is X 1 2 3 4, but at the bottom there is no X. So as per the definition given, a region is surrounded if none of the O cells in that region are on the edge of the board. So but this O is on the edge, so we cannot surround it completely, right? So now let's try to understand how we can solve this. This can be solved in 3 steps. One is converting all the edge O's to some letter, let's say A. I'm taking any letter which is not O and X so that we can uniquely identify it. And then replace all O's with X. Nothing but the O's which are not on the edge. And then for the third step, we have to replace all our A's to O's. We'll discuss this in detail now. So first of all, any cell we can traverse 4 sides R comma C, and it will be R minus 1 comma C, R plus 1 comma C, R comma C plus 1 and R comma C minus 1. These are all the coordinates which any particular cell can traverse towards. And we have to, first step is replace edge. Edge is nothing but first row, last row, first column and last column. These are the edge cells. Wherever there is a 0, let's say for example there is a 0 here, 0 here, we are not going to replace this entire region. So we have to do a DFS instead of just running a for loop for 0th row and last row and 0th column and last column. That is the reason we are going to run DFS for this, to ensure that all the O's are converted to A. And then once this O is converted to A, there are all the O's which can be converted to X. So we are going to convert them to X by just running a for loop, and whenever it is a O, we are going to make it as a X. This step is done. And then once we got this, if you see, the only difference between this board and this board is that we have to replace all A's to O's. So again we will run a for loop and we will replace our A's to O's. So this will be again replaced as O, and this is how we are going to return our answer. And in the question they have mentioned that we have to make all the changes in place, so we don't have to return anything else. I hope the solution is clear. Now let's try to code it up. You'll understand it even better. So first, convert all O's to any letter. I'm taking A here. And then second, this is only for edge. And then edge region O's. Why am I calling edge region? Because if I had O here and here, this entire region would have been part of, like, they all has to be replaced to A. So it's not just a single O, but all the O's which are on the edge, or region which is on the edge, right? And then once we convert O's to A, all other O's should be converted to X, and then all A's should be converted to O's. So let's have rows. It is nothing but board dot length, rows length, columns, number of columns will be board of 0 dot length, and then we will define our DFS method, which will just take current row comma column. So in this DFS, what should happen is we will check our bounds, which is simple. Or even if the board of R comma C is not equal to O, then also this does not apply to us, so we will just return. Else we will mark our board of R comma C to A, and then we have to do DFS of R plus 1 comma C. There are 4 directions which we go into: R minus 1 and R comma C plus 1 and R comma C minus 1. So these are all the directions which we travel into. Now this will happen only for the edge rows, 0th row and 0th column, last row and last column. Let R less than rows, R plus plus. I'll just write the for loop and add the conditions. So if R is equals to 0 or R is equals to rows minus 1 or columns is equals to 0 or column is equals to cols minus 1, this is nothing but we are checking the first and last columns, and we have to do a DFS only if board of R comma C is O. Otherwise there is no point of doing all of this DFS. So we will call DFS of R comma C. We are done with our first step. Now we are left with our other 2 steps, and we have to iterate over all the elements and then convert whatever are O's. We will convert it into X. So if there is a O, any other O apart from the edge ones, we will convert it into X. And third step is all A's should be converted to O's. So now let's try to run this code. Submit it. It works. Now let's try to understand the time and space complexity of this solution. So basically this entire thing is m cross n. So in the worst case, if all the elements of the board are O's, then this DFS will take big of m cross n time, right? And this is again, like it will take at max m into n, and same here. So it would be big of m cross n, and the space complexity of this solution would be m cross n, because if the board contains all O's, then the recursion stack will grow up to m cross n. That's the reason it would go up to m cross n.